Hello everyone, I'm A.B.M.Salman Rahman, Master Integrated Doctoral Fellow, Department of Information and Communication Technology, Suncheon National University, Changsun, South Korea. As everyone know, environmental food and nutritional protection primarily depend on pollination, and mostly 75% of pollination has done by honeybees. People are commonly utilize honey for their daily ethnic food. Based on demand, beekeeping is increasing rapidly. And this is the high time to support farmers by technology for getting high production of honey from beekeeping. Today I am going to present a systematic analysis of environmental issues on ecological smart bee farm by linear regression model.
About. As I told earlier, environmental food and nutritional protection primarily depends on pollination from honeybees. And people are commonly utilize honey as a portion of ethnic food. Based on demand, beekeeping is increasing rapidly, and farmers are using different types of methods for beekeeping to get high production of honey. The main purpose of this study is to present the results of different types of environmental factors and 3 different honeybee farms from using linear regression model. Farmers have to consider different types of environmental factors. And this is the high time to support farmers by technology for getting high production of honey. In our study, we have 3 honeybee farms and we collect our environmental data from that farm. We use linear regression model for getting prediction results. Introduction. Honey is one of the leading ingredients in conventional food culture in different areas of the world. And also the main products from beekeeping is honey. Traditionally, beekeeping has been conducted with various places as a part of the local community and also an occupation related to the production of pollinators. Beekeeping is so much popular in several countries all over the world. For example, honey is an essential component of food culture in countries such as Japan, Korea, Bangladesh, India, etc. The preservation of beekeeping and honey production will also contribute significantly to the sustainability of the food culture. Beekeeping history in Korea. In this slide, we are going to show a short history about beekeeping in Korea. Korea has a long history of beekeeping. More than 2000 years ago, beekeeping began in Korea. In Korea, beehives numbers are around 2 million and honey production varies between 20,000 to 27,000 tons recently. About half of the counties on the Korean peninsula engaged in beekeeping. During the Joseon dynasty in 2002, exotic bees in Korea accounted for 83% of beehives. Exotic bees are already dominant. Native species are usually kept deep in the mountains, while exotic species are kept at the edge of mountains areas, including agricultural areas. For honeybees, there are 2 types of species are available for the Korean beekeepers. 2 species are native Korean honeybee and western honeybees. The western honeybees first introduced into Korea in the early 19,000. Contents. Rest of the slide will discuss about method description, dataset description, result and discussion, and conclusion. In method description, we'll tell about linear regression model. In dataset description, we'll tell about our datasets and we visualize our data in plot. In result and discussion, we will shows the prediction results by linear regression and then conclusion. Linear regression. Linear regression is a modeling technique to find out the relationship between scalar dependent y variable and one or more independent x variable. Two types of regression models are simple linear regression model, multiple linear regression model. In simple linear regression model, there are only one independent variables, and for multiple linear regression model, there are two or more independent variables are available. We assume linear regression multivariate model for our study. Here y equals beta naught plus beta 1 x plus error term. Here y is the dependent variables, x is the experimental variable, beta naught and beta 1 are two unknown constants that represent the intercept and slope, also known as the coefficients or parameters, and e is the error term. Data description. In our study, we used 3 Smart Bee Farm environmental data for every minute from March 2020 to April 2020, which is consist of 53,826 rows and 6 columns. In this Smart Bee Farm dataset, there are various kinds of categories data, including with date, like bee box outside temperature, bee box inside temperature, bee box humidity. From 3 Smart Bee Farm naming, like for farm 1 bee box 1, farm 2 bee box 2, for farm 3 bee box 3. For every farm, outside temperature, inside temperature, humidity are also different. Data visualization for outside temperature. In this slide, we can see 3 box plot. First one is box 1 outside temperature for farm 1. Second one is box 2 outside temperature for farm 2. Third one, box 3 outside temperature, this is for farm 3. All graphs are in box plot. From box plot, we can see the maximum temperature for every day, the lowest temperature for every day, and also the average line. That all plots are showing the maximum temperature, minimum temperature, and average line for 3 farm outside temperature. Data visualization for inside temperature. This is also same as box 1 inside temperature for farm 1, box 2 inside temperature for farm 2, and box 3 inside temperature for farm 3. From figure, we can find out easily everyday maximum temperature, minimum temperature, and average temperature by box plot. That black line, this black line is for average temperature, this is for maximum, and this one is for lowest temperature for farm 1, day 1. Data visualization of humidity for 3 farm. In this slide, we can see 3 farm inside humidity. Box 1 humidity for farm 1, box 2 humidity for farm 2, and box 3 humidity for farm 3. And from 3 slide, we can easily find out the maximum humidity for every day, minimum humidity for every day, and also the average humidity for every day of 3 farm. Result and discussion. In the result part, we analyze outside temperature, inside temperature, and humidity for 3 Smart Bee farms by using the linear regression model to find out the best prediction results among 3 Smart Bee farms. Here we can see 3 plots. First one for farm 1 outside temperature actual value with prediction line of linear regression model. Second one for farm 2 outside temperature actual value with linear regression prediction line, and third one for farm 3 actual value line with linear regression prediction line. From all three figures we can easily say that prediction lines are very close with actual value line. R-square value and standard error value for 3 smart bee farm outside temperature. To find out best prediction results among 3 smart bee farm, we use R-square value and standard error value. As we know that if R-square value is close to 1 and standard error value is less than 5, then the prediction model is good enough. From table we can see that for all 3 farm R-square value is close to 1 and standard value also is less than 5. For farm 1 R-square value is 0.93 and standard error value is 1.33. For farm 2 R-square value is 0.92 and standard error value is 1.41. For farm 3 R-square value is 0.95 and standard error value is 1.13. If we make a comparison among 3 farm, then we can find out that box 3 is giving good result than other 2 farms, because for box 3 R-square value is 0.95 and standard error value is 1.13. Bee box inside temperature analysis. Here we analyze 3 farm inside temperature with prediction value. First one for farm 1 inside temperature with prediction line, second one for farm 2 inside temperature with prediction line, and third one for farm 3 inside temperature with prediction line. And from here we can easily say that prediction lines are very close with actual line. Here blue line for actual value and red line for prediction value. R-square value and standard error value for 3 smart bee farm inside temperature. As I told before, for getting best prediction results among 3 farm, we use R-square value and standard error value. From here we can also find out that farm 3 giving best prediction result, because among 3 farm 3 R-square value is close to 1 and standard error value also less than other 2. For farm 3 R-square value is 0.95 and standard error value is 1.09. From here we can easily say that for inside temperature farm 3 giving best prediction results among 3 farm. Bee box inside humidity analysis. Here we can see 3 farm actual value of humidity in blue line and the linear regression prediction line in red. Bee box 1 humidity is farm 1, Bee box 2 humidity for farm 2, Bee box 3 humidity analysis for farm 3. And from here we can easily say that red line is close enough with blue line. It means actual value and prediction value is close to same. R-square value and standard error value for 3 smart bee farm humidity. From table we can easily say that box 3 R-square value and standard error value is better than other 2 farm. So we can say that farm 3 giving best prediction result among 3 smart bee farm. comparison results of R-square value and standard error value for 3 smart bee farm. Here we accumulate 3 farm analysis result in one table. Box 1 for farm 1, box 2 for farm 2, box 3 for farm 3. From the table we can say for outside temperature, box 3 prediction result is better than other two. For inside temperature, box 3 results is better than other two. And for humidity, box 3 results is better than other two. So after analyzing all results, we can easily say that farm 3 is giving best prediction results among 3 farms. Conclusion. The honeybee offers numerous natural ecosystem, included agriculture, crop pollination, as well as direct beekeeping industry source of revenue, such as honey, wax, pollen, and beeveum. This study focused on find out the environmental factors prediction by using the linear regression model and find the best smart bee farm among 3 smart bee farms for getting good prediction results. All results and analysis give us acuteness between environmental factors, predictions, and smart bee farm. Results are about 3 different types of environmental factors for 3 different farms, and from results we find out that Bbox 3 or farm 3 gives us the best prediction result among 3 smart bee farms. So after analyzing all environmental factors, we can say Bbox 3 or farm 3 is better than other 2 farms for getting good production.
That's all from me, and thank you all for watching my presentation. Stay safe. Goodbye.